If you are watching this video, it means the giant magnet I am holding in my hands has not erased the SD card in James's camera, and that is a good thing.
It's a good thing.
Let me very carefully take this sheath off. All these pieces of steel all put together in this big horseshoe shape and then sheathed with this.
So the question is, Brady, how do you make a magnet if you don't have one already?
No, the question is, Keith, how do we know this is a magnet? We haven't proven it.
Let's go.
You ready?
Yep. Goodness, it works. So we definitely have one.
And you were saying this is about making magnets.
It is, yes. This particular one was made by John Canton. He made his scientific mark constructing magnets.
Okay.
His paper was published in the Philosophical Transactions, and it's very much a how-to guide. If you want to make a magnet, this is how you do it. He was awarded the Copley Medal for this. It was judged so important. You get more money for the Nobel Prize, but the honour of the Copley Medal is quite something.
It's a big deal. And this is Canton's paper explaining how he did it. And more importantly, we've got this nifty little fold-out section here. You could also figure out how to wear big fluffy things on your hands. What is with those?
Well, we need to attach those to your gloves for next time.
Do you think they would look good?
I think that would look good.
Yeah. What's the illustration we're looking at, Keith? What's going on here?
Well, he's showing a bar of iron here, which is secured to a poker by a thread of silk and some tongs there. And the methodology here is just to stroke the metal. So he's stroking that until he gets a light magnet, and then he's using series of other bars, other metal bars, and continuing that stroking process until he creates, right at the end here, a very powerful magnet.
Like a big magnet sandwich at the end there.
But he wasn't the only one. Quite a few people were investigating magnetism at that time.
Okay.
And he had a slight rival.
Okay. This is where things are going to go a little bit off track because there's something else we want to show you that's not exactly magnetic. Pun alert. Put the pun alert on the screen now, James. He did have a rival in the magnetic field. In fact, you could say...
they were poles apart.
Who was that?
John Mitchell.
John Mitchell. Let's put this paper away then. Canton's award-winning, Copley Medal award-winning work, and talk about Mitchell. But we're not going to talk about his magnet work.
Well, he was very, very versatile. So he wrote a book about magnets in just the same way as Canton presented that paper. How do you make them? What do you do with them? But he was interested in lots of other things.
All right.
And this is one of his astronomy papers that he wrote to a very famous physicist, Henry Cavendish. What Mitchell is interested in at this point in his career is gravity and how one can observe double stars. This is his paper around that topic.
What have we got? 26th of May, 1703?
That's right.
Okay, John Mitchell. With much respect and esteem, your obedient, humble servant. They're so polite back then, Keith.
You can see what he's writing about here, the method which I mentioned to you when I was in London, by which it might perhaps be possible to find the distance, magnitude and weight of some of the fixed stars by measurement of the diminution of the velocity of their light.
Don't panic. Things are about to get really interesting.
In this paper, Mitchell speculates that one might get an example of a star or an object whose gravity was so great that light couldn't escape from it.
So basically, what's being hinted at here for the first time is a black hole.
If there should really exist in nature any bodies whose density is not less than that of the Sun and whose diameters are more than 500 times the diameters of the Sun, since their light could not arrive at us, or if there should exist any other bodies of a somewhat smaller size which are not naturally luminous, of the existence of bodies under either of these circumstances, we could have no information from sight.
We couldn't see it?
Couldn't see them, yeah. But he goes on to say that one could infer their presence from bodies in orbit around them.
I mean, it wasn't that long ago that we saw for the first time the supermassive black hole at the centre of the Milky Way, and they've managed to image all the stars going around it. So even though you can't see the black hole, you can see the stars moving around it. That's exactly what he's talking about all these years ago. I kind of wish I could go back in time and say, guess what? Guess what?
Yeah.
Look at this.
You know, it's the same argument. It would be great to live a couple of hundred years to see what people discover in the future. But you can't have everything.
You can't have that, and like everyone realises that, but you're almost exposed to it on a daily basis.
Yeah, and it's interesting, it's fun. Sometimes it's quite touching, but always exciting, I think.
There you go. We started with a big magnet. We've ended with black holes. Who would have thought?
Not bad.
This is amazing, this book. Is this one of your like jewels that you show visitors to?
Yeah. When I do the staff tours around here, and when
So
we have
basically,
VIP visitors as well.
You're showing off right now, basically, aren't you?
Yeah.
Okay. That's all right. I'd show off too.
I'll admit that, yes.
I'd show off too if this was my book.
So that's the Wheel of Fortune. It's a sort of concept which was very popular in medieval times about how fate acted on the human world.